В нас зараз доповідь від Кіфа Морріса. Вона буде проходити англійською мовою, тому переходжу на англійську. Today we'll have a talk from Kief Morris. Kief Morris is a global lead for cloud technology at ThoughtWorks. He's also an author of O'Reilly book that's called Infrastructure as Code. And he works with many ThoughtWorks clients around the world to explore better ways to apply cloud and infrastructure technology to help teams deliver strong value more quickly and reliably. Originally from Tennessee, Kief moved to London in the dot-com days and has been there ever since. And as a fun fact, Kief's family cat, Jax, loves to play fetch with his toy mouse, and he's never known a cat to play a fetch. Kief, welcome to Software Architecture Fwdays.
Thank you very much. Yeah, it's great to be here. So, shall I get started? Right, so my topic today is scaling infrastructure as code. And what I mean by this is how do we design and build infrastructure on cloud using infrastructure as code in ways that help to meet whatever our organization might need to do in terms of its kind of strategies, right? So our organizations might have different strategies which drive requirements from the infrastructure that we build. So in terms of growth, there are a number of things that organizations may be trying to do. Volume is the obvious thing. They might be just trying to grow the number of users, the number of transactions, just what's going on in the platform. And obviously, we need to be able to design and build our infrastructure to meet those needs. A lot of clients I work with are expanding. They're looking to grow and to be able to grow into other regions. And so they have to think, or we have to think as the ones building the infrastructure, how do we handle going into other regions? Do we need to stand up instances of infrastructure in other parts of the world? If we do that, how do we go about doing that? How quickly do we need to be able to do that? So a lot of organizations, especially fast-growing ones, want to be able to go into a new region quite quickly, and so we need to make sure that our infrastructure is something that we can do that. It's also common for an organization to be looking to grow the products, a number of products that it offers, new products, improvements to products. And so again, that can affect how we think about how do we make sure we can stand up the infrastructure needed to develop, to test, deploy, and run new products, and how quickly do we need to be able to do that to help the business do what it's trying to do. And then another thing, so a couple of clients that I've worked with tend to do a lot of acquisitions. They buy other companies, often to do those other things. Maybe they're buying companies so that they can, in another region, so that they can expand their business into that region, or maybe they're buying companies to add products to their portfolio. And again, with infrastructure, our concern is, well, how do we fold that in? How do we kind of integrate other organizations and make it easy to kind of do those integrations? In addition to growth, our organizations may just be looking at effectiveness, right? So technology modernization is quite a common thing as organizations try to move away from older legacy technologies and platforms like mainframes even, as well as maybe older types of Unix and those kind of things, and move into the cloud, adopting cloud native technologies, serverless, and that kind of thing. So again, this is obviously something that we have to help them with. By cost alignment, I mean, they may be thinking about how to manage. In some cases, organizations, in a lot of cases, they're hoping that we're going to reduce costs by moving to the cloud. That's often very tricky. It often doesn't work out the way that people hope. But also there's the idea of just being able to match the costs to demand. So as demand goes up, how quickly can we provision more infrastructure in order to support that? And then how can we ramp down if whether it's due to time of year or economic conditions, can we reduce our infrastructure footprint and cost quickly in order to meet that? That's often one of the drivers for adopting cloud and using infrastructure as code to do that. And finally, it's operational quality, right? And by this, what I mean is they may be, and again, looking at it from the kind of higher management point of view, they may be worried about, is our performance fast enough? Are we hearing about problems with that? Are we stable enough? What about security and those kind of things? So these are all things that as the folks who are designing and building and leading with infrastructure implementation, we have to make sure that we're aware of what our organization is trying to do and what they need from us. And so the challenge is that our infrastructure, especially here, I'm talking about infrastructure as code. So in those situations where maybe most organizations have already started, they're using cloud at least to some degree, and tend to be using infrastructure as code tools. And then what happens is, as the businesses are trying to do those things that I was talking about, the infrastructure, we run into problems with the way our infrastructure is implemented and the way we've built it, right? So this often starts with code sprawl. And what I mean by this is, as we grow and we add more things into our infrastructure, how does our code look? Our code base may grow organically. So in some cases, what happens is let's say we have a Terraform project, we're adding more and more things into that project, and it's getting bigger and bloated and messy. So that's one way that things kind of go into sprawl. Another way that things sprawl is that we look at, when we're doing those things, or how do we expand into another region or add another product or another team, maybe we copy the code that we have from one project and make a new project. And so we end up with lots of copies of code. A lot of clients I work with, they end up with both of these. Their code base grows and they have multiple copies. And so then what happens is it becomes inconsistent. So maybe we make changes to newer versions of the code, or for code for this project or that country, and those changes may not get made all across the other parts of the code base. And so everything gets messier and messier. And that makes it hard to change things. And I think one of the things that people often think about infrastructure is that we don't really need to think about making it easy to change our infrastructure, because we view it as a one-time thing. We build an environment and then it's done. In practice, we often need to change our infrastructure a lot more often than we expect. If you think about it, think about security patches and system patches, and then those minor version updates of core system components, things like databases, Kubernetes clusters, and all these kinds of things that we're supporting. We need to be able to kind of keep updating those all the time, or we end up with things that are old and out of date, and then we end up with again, a very messy code base and very messy systems where we have different versions of things, and we're having to support old things as well as new things. And that means we spend a lot of our time as infrastructure and operations people on work that is less valuable. It's not really helping to support those goals. It's more just keeping things running and keeping things together. So we may be spending a lot of time on kind of scripts that we use to manage things. We may be spending a lot of time just kind of going and trying to make fixes and improvements across that messy, sprawling code base. And then another thing that I'll talk a little bit about is how our infrastructure can often disempower teams, those kind of product and delivery teams that are building things on top of our infrastructure. A lot of times the way that our infrastructure works and the kind of hassle that we have of trying to manage it all means that those teams aren't able to get their work done as well as they could, and that creates kind of dissatisfaction and all kinds of problems. So the things that I'm going to talk about how to deal with these challenges are what I like to call a collaborative platform, a collaborative way to implement platforms. Rather than thinking about having a single team that builds all of the platform, how can we have multiple teams and even the kind of product teams working together to build different parts of the platform? And this requires a composable infrastructure architecture. So it's building our infrastructure not as kind of a big blob of infrastructure code, but as code that is nicely organized that we can kind of fit together in different ways. And very key is supporting the continuous evolution, continuous improvement of systems, not only the stuff that runs on top of infrastructure, but the infrastructure itself. How can we kind of keep it going and updating and improving? So platform is the way that we tend to look at this, right? We tend to say, we've got a cloud, it provides infrastructure, we've got platform services that maybe we have some platform engineering teams. Platform as product is something that we like to talk a lot about. And then the application sitting on that. So we think about that in that kind of a layered structure. Now, one pitfall that I see organizations falling into, and this tends to happen maybe a little bit more at the higher level of technical leadership, is they say, well, we don't need a platform because we have the cloud. We're buying, we made a deal with AWS or Google or Microsoft or somebody, and so now we have a platform. We can just let our developers use it. We don't need to spend time on the platform. Well, the thing is, what the cloud vendors provide us is not really a nice platform. It's a box of parts that we can use to assemble our platform, or developers can use to assemble our platform. And so that gets quite messy, right? So Corey Quinn, who writes the weekly email newsletter Last Week in AWS, he wrote a post that he talked about 17 different ways to run a container on AWS, right? And what this represents is that, if you just let developers loose on cloud, like, they can do things in all kinds of different ways. He also wrote a follow-up article called 17 More Ways to Run a Container on AWS. So the problem with just letting people go uncontrolled onto the cloud platform is that you end up with a lot of inconsistency and overlap. So you might have like multiple different implementations of Kubernetes all across it, people doing similar things. And that can make, again, the changes, as I've talked about the importance of being able to make updates and patches and all those kinds of things for our infrastructure. The more things you have that different teams are doing in inconsistent ways, the harder it is to do that, especially where there's dependencies between them, because this one team changes something and it breaks what another team is doing. And so you need to have then a lot of overhead and bureaucracy about making changes. And that's kind of just slows everything down and often doesn't actually fix the risks of changes. It just makes it all harder. Also, you have the cost thing is a big issue, as I kind of touched on. When you've got people using cloud, it's very easy to create more and more things, which runs up costs. And so it can be difficult to see, and so people can be surprised when they see the bills that we're racking up for them. And then the operational quality, right? So some teams might do very well at making what they build secure, and some teams might not know how to do that as well. And same thing with stability and performance and all those kinds of things. And so you're kind of losing out the way to benefit of where people are very good at doing that. How can you kind of capitalize on that and use that across? The other approach is the paved road idea is a nice one. This is the idea that we're going to build things for developers to make it easy for them to do things. What sometimes happens, though, is that paved road is just a tunnel. Really, the idea of a paved road should mean that you're able to kind of go off the road where you need to. But in too many organizations, the platform is seen as something that, in essence, it disempowers developers and product teams, right? Because if you're looking to build a platform to force developers to do things properly by not letting them do anything else, that's disempowering them. Or you might be trying to help developers by hiding things that they shouldn't need to understand. And so that means they can't see those things, which can be make it difficult for them to build things properly because they don't understand what's going on underneath the things that they're deploying. And also just this idea that platform capabilities are only provided by this one central team and nobody else is allowed to kind of touch these things. And so all of that means that the teams that are using this stuff don't have the kind of power necessarily to do what they need to do. If you take an empowering view of a platform, you should be, in order to do that, you should be making it easy for developers to do the common things. Look at the things that they tend to need to do. Just make it easy for them to do that. Not forcing them to do things a certain way, but just making it easy for them to do those things. And when it comes to platforms and abstraction layers and these kind of things, the useful thing is rather than hiding things from people, it's about letting them focus on the context. So when I'm writing an application, I want to be able to write the business logic and think about that and not have to think about, how does the storage devices work, and optimization for that. But I would like to be able to shift my context when I'm finding that actually I'm having problems with latency. I want to be able to shift my context and understand what's going on in the other parts of the system. I need to be able to understand the networking and the storage systems and so on, so that I can optimize what I'm doing to fit with that. There's this idea of mechanical sympathy, which is the idea that it is useful for developers to understand what's going on all the way down the stack, because it helps them to do what they do better and helps them to debug issues and problems better. And basically, we should be looking for ways to enable teams to add and extend and modify the capabilities that are provided by the platform, rather than, again, kind of locking them down. So this is kind of a goal for this. So some of the kind of drawbacks or the bad things that often come out of being overly centralized when it comes to platform is that it limits what teams can deliver. They're only able to do whatever's been built for them. And if they need to do something new, they may not be able to do that. Or if they do, that might take a long time, right? So I think of examples like where machine learning and data science and this kind of stuff it's risen up over the past few years. And so how quickly can you provide? And it's still changing, right? The technologies that underpin that are changing. So how quickly can we get things into the hands of those teams to be able to do new things rather than say, well, you can't do that. We're going to have to stay behind. But everybody else is doing the modern things with machine learning, but we're kind of going to be a few years behind because we don't have enough people to do that quickly, right? And we're reliant on that centralized platform. What often happens is that this drives high priority work elsewhere. So I work with some clients where the platform team is trying to build this platform and they're supported by, say, a CIO who says everybody must use our platform. But then what happens is there's work in parts of the organization, product work and services and so on, which are very high value and very important, high priority to the top level people. What happens is when the teams working on those say, well, the platform isn't helping me, it's getting in my way, then the top level people say, well, ignore the platform, do what you want. And this kind of degrades the whole idea of the platform and keeps people from adopting it. So I think it's important to make sure that we're able to do this well, right? So I talk about a collaborative platform architecture and the kind of things that I think we can do to make this work. So one thing is it's establishing clear standards for providing and consuming those platforms services, right? So if we're taking an architectural point of view, the goal is not to kind of define what is everybody doing and how are they building it, what are they building. It's more saying, look, this is how you should be integrating between what different teams are doing and standardizing that and making that work well. And thinking about the boundaries between these platform services on a kind of a domain-based approach, right? So what I mean by that is traditionally in IT and infrastructure, we often are very technology focused in how we organize things. So you may have like a database team, or in some cases you have like an Oracle team, and you have a Cisco team, and like teams are based on technologies, specific technologies, a Linux team, and so on, rather than what they're trying to provide in that kind of more abstract way. So taking a kind of domain-driven design approach that normally starts with the kind of the business functionality and what we're providing to our end users, and thinking about that down into the platform services. So we start thinking about identity management rather than a specific tool. We start thinking about traffic management rather than just networking. And so we start thinking about the problem that we're trying to solve and how we can provide that. And so thinking about that in terms of aligning the teams structure and the architecture so that those work together is really important. And also another thing for this collaborative platform architecture view is we want to encourage people to extend and add capabilities. So in the case of here, let's imagine that team over on the right is a data science team, and there's a new machine learning product, service, what have you, that they need to implement. And so rather than saying, well, you can't do it, you have to wait for somebody else to build that for you, especially given that it's only this one team that's going to be using it. You can say, you can go ahead and build it, but here's how, right? We're providing the architectural kind of guidelines of how do you build it, how do you consume other services, and if later on you end up wanting to share it, here's how you can kind of make it shareable in a way that's standardized and fits within everything else, right? And then we want to be able to provide scaffolding for delivering the changes. So if we've established these standards of here's how you interface, here's how you integrate different parts built by different teams, you may need to have tooling around there that makes that easy to do. So there's kind of a couple levels here. One is you can think about as a developer enablement interface. And so this is basically how does a product team, an application team, development team, how do they use platform services? And there's a lot of things around. There's things like developer portals, and there's things around descriptor languages. So obviously there's things like, say, Helm charts, and then also broader things like OAM, the open application model, and so on, which are trying to build standards for how to write, descriptors that application teams can use to kind of define what they need from the platform. And so making that a kind of clean and clear interface is really helpful. And then this is where I'm going to be focusing a little bit more in the rest of this talk, is on the kind of infrastructure scaffolding. So this is basically your infrastructure as code, taking those things that the cloud provides and assembling them together into services and doing that in kind of a nice, well-designed way that helps us to kind of achieve those goals that I've been talking about. So how do we do this? How do we implement infrastructure as code for scale? And I talk about scale, I'm thinking particularly, because I've been talking about these kind of collaborative platforms, is more and more people, more and more teams. Might be regional teams, might be product teams, might be teams providing platform capabilities. So more and more teams and people who are building infrastructure, building platform services, and using those and working together on those. And the key to this is really design. It's how do we design our infrastructure code? And I think it's important to draw from lessons learned from software engineering. So I think there's been some other kind of talks talking about principles of say object-oriented design, other types of software design. I think it's important to kind of something I think we haven't done enough of in the infrastructure world is think about how to use those lessons for our infrastructure code, and so that's where I'm kind of focusing on. So Dan North, who's a former thought worker, has recently published an article, and he's kind of talking a bit these days about what he calls Cupid. And it's this way of thinking about the design properties of a system. And so what he talks about is, so the Cupid stands for, the letters stand for these things. First of all, composable. A composable system, you want to design your system so it's composable, so you can make different parts and put them together and reassemble them in different ways. And you can do that with the Unix philosophy, by which we mean making those small pieces. If you look at like the command line utilities that Unix and Linux provide you, they're small pieces, each of which, they're small tools, each of which does one thing and does it well, and has very clean and simple interfaces so that you can put them together. Predictable, obviously, you want your system to be, when you write code or look at code, you want it to be doing what you expect it to do. Idiomatic is basically about making sure that when people are working with, say, infrastructure, that the tools that we're providing or anything that we're providing them fits with how those things are supposed to work. So working with AWS is in an AWS way, rather than trying to provide an abstraction layer which hides it and makes it look like something different. And then domain-based. And again, this is thinking about how we design our systems, not based on necessarily the technical aspects, but on how it's used and where it fits in the system. So I'll give a very simple example here. Again, looking at those layers of the platform. I've been working lately on a very simple, bit of infrastructure code for hosting websites, static websites on S3. I use Jekyll to generate my content. So that kind of works like an application. And then I have some code that kind of sets up the AWS infrastructure to host it on, right? And so the bits that I need in terms of the infrastructure from the cloud, I need an S3 bucket to store my web pages and images and so on. I have some kind of networking stuff, so I have DNS entries. I have SSL certificates for the kind of domains, and I have kind of Route 53 for the content distribution network. So that's all code, that I have to write, or infrastructure that I need from my cloud, and SSL, and also roles. So IAM security roles, which basically define the access to be able to change content, upload content onto my website. So I define that as code as well, as a whole part of this. And so this is like one project. Right, I call this an infrastructure stack. So I have like a Terraform project which defines all this stuff. And so when I talk about an infrastructure stack, this is a way of thinking about how code is architected and how systems are architected. And the book Evolutionary Architecture talks about an architectural quantum. And what they mean is an architectural quantum is what is the unit that you deploy together. It's a cohesive kind of unit of code that is separately and independently deployable from others. So obviously with a monolithic system architecture, that's one big architectural quantum that you deploy all together. With microservices, you have very small, the architectural quanta are the small services, each of which can be deployed on its own. And so that's kind of just a way of thinking about that. So with infrastructure code, an infrastructure stack, that's a term that I use as kind of a platform or tool agnostic term for a project of infrastructure. Again, that you're defining and deploying as a unit. So a Terraform project with a state file, right? What does one state file correlate to as an instance of infrastructure for Terraform? Or with CloudFormation and CDK and Plumi, they all use the term stack as well, which is nice because it goes together. And the thing to consider when it comes to kind of how our architecture kind of demands, as the stack grows, the surface area of a change grows. As we get more and more code into that project I'm talking about, it takes longer to apply changes, right? Running Terraform apply can take longer and longer. I worked with one team here in London where running Terraform apply would take 2 hours for it to complete, right? Because they had so much code in there. And that means a larger blast radius for the changes. So if something goes wrong, you might only be changing one little thing in your infrastructure code, something that seems trivial, but then what happens is because other things are affected by that code that you're applying, something else can change that you weren't expecting to change. And it's harder to kind of find and fix problems because something breaks when you run it, and you have to go through all of that kind of code and all that kind of infrastructure resources to figure out what exactly went wrong and how do I fix it, and how do I fix it in a way that doesn't break something else, right? So basically, as the code base grows, as the size of a stack grows, the barriers to change and improve it grow. So people often ask about modules, especially with Terraform. With other code bases, there's libraries, right? So, isn't this something that we can use to fix this problem? It doesn't actually fix this particular problem, right? Modules are handy as a way to organize your code and make that kind of, you organize your code base where you've got a lot of files and so on. And that's nice. But it also adds moving parts, because now you have to think about versioning different modules and like distributing them and pulling them together, and so that just adds some complexity. I'm not saying it's not worth it, but it doesn't reduce that scope of change, that problem I talked about. So if you took that project, that team that I worked with that took 2 hours to run Terraform apply, and you broke it all out into modules, it would still take at least 2 hours to deploy, because when you run the Terraform apply command, it pulls all the modules together. You still have a very large quantum of architecture, a quantum of change, scope of change. So at the modules tend to add more barriers to change than they necessarily reduce, other than being able to kind of find code and kind of organize and reason about your code. So the approach that I advocate is splitting infrastructure across multiple stacks, multiple projects, right? So taking that if I decide that like there's too much going on in my static website hosting project, I'll break it into a couple of different ones. So here I broke it into one project that has the S3 bucket for content by itself, the security roles and policies I put into another project, and then the networking things I put into a third project, right? So now I have 3 different projects, each of which can be changed by itself, which is nice. But of course, there's a trade-off, right? As with microservices, this is really drawing from the ideas of microservices, we're moving complexity to those boundaries between the stacks. So we have dependencies across stacks which create coupling, and they can potentially be coupling on those things inside there. So one step to kind of start to manage this better is to define interfaces at the stack boundary. So in other words, rather than saying, my S3 bucket and an IAM policy that I have, are tied together, rather than having, say, the code from one project going and finding the thing that it depends on from another project, maybe because it knows what it's named or a tagging or so on. It shouldn't. It should just say, I need you to provide me an IAM policy or a reference ID or something, and then I'll use that. And so it means that those stacks don't know too much about each other. This is about using software design principles, kind of age-old, many decades-old principles that we have about reducing coupling. I'm talking about things like the law of Demeter, which says the one infrastructure stack or one kind of component shouldn't know how another one has been implemented, right? I shouldn't need to know what you named, say, a subnet that you've created in your networking project so that I can deploy something into it. I shouldn't know what your tagging is. I should just kind of know, give me a subnet ID. And so having those interfaces kind of defined, clearly at the outside of those stacks is what helps us kind of manage these. And this can also help us to avoid coupling to the tooling implementation within those. So it's actually possible that you can have stacks where one stack is built using Terraform, another one might be built using Ansible, another one using CDK. And so this kind of creates some ability to kind of keep those things loosely coupled, or even just versions of your tool, so that if the new version of Terraform comes out, say, and it has some kind of important changes, you don't have to upgrade all of your code at once. You can upgrade a piece at a time. And so in thinking about where to draw those boundaries between your infrastructure stacks, there's different ways we can think about how to align those boundaries. One is around the speed and frequency of changes. So it may be that some of your infrastructure, some pieces you tend to change more often, and some you change less often. Maybe I change DNS entries a lot because I have microsites and things that I'm doing. So I'm often creating, doing things with my DNS entries. I don't need to make changes. I don't need to make changes that can affect my security policies and my S3 bucket. Every time I do that, right, I can kind of break that apart and kind of control the boundaries of what I'm changing and when. And then also data persistence strategies. So for example, that S3 bucket, I might care about that content. I might be able to regenerate that content and deploy it if I rebuild the bucket. But that's heavier weight, right? So I might want to be able to kind of replace other things and build other things and mess around with them. And I don't need to worry about persistence. Whereas when I change the S3 bucket, I might say, whenever I change it, I might do a backup first, right? So when I run my command, I run my script that is going to make a change to the code for the S3 bucket, I'm going to do a backup of the content on that bucket. But I don't need to run that. If it was all in one big project, I would be running that script potentially every time I change everything, even though I don't need to. So this is kind of helps to think about those kind of things. There's also the kind of governance and risk of changes. So it may be that my InfoSec team says, we want you to have some extra controls whenever you change those roles, those IAM security policies and the like. And so I can put those kind of policies around, change controls around that project, that stack, but I don't need to run them for the others necessarily, because the InfoSec team may not have those requirements for those things. And so that's useful to be able to kind of separate them out in that way. That can also really helps with compliance with things like, say, if you have PCI compliance and other kinds of those kinds of government and legal compliance. Often those will only affect certain parts of the system that maybe handle, say credit card numbers and those kind of things. So it's nice to be able to separate those out. And then there's the team ownership and domain of changes, because one of the issues you get with those big infrastructure projects is you have multiple people in multiple teams who might need to make changes to those. And so you have conflict. And again, you have to have overhead and bureaucracy to coordinate that. Well, I'm changing something. I need to make this fix. Somebody else is already making a change. It's not ready to go yet. I have to wait for them. We have to kind of make schedules and all that kind of stuff. If you kind of break those apart and say each thing is only owned by one team, that team is able to move more quickly. And the way that we move is we use pipelines. Just as we do for application code, we use pipelines for our infrastructure code, right? So we have in each stack, we're pushing the code through, and we have different types of tests that might happen. We might have tests that run in kind of a CI server, and it runs without using the cloud. Maybe it uses something like local stack. And then we progress on to another stage of our pipeline where it does use the cloud. And we have later stages of our pipeline where we integrate those stacks together, right? So this is one thing that helps with that loose coupling, right? Because what will happen is you'll have these kind of stacks and you'll say, well, how do we make sure that these are loosely coupled, that I can change one easily, that those interfaces and boundaries between them, that those designs are enforced, those constraints and interfaces are forced. And so what we can do is we can use test fixtures, right? So for example, if I have a stack that requires another stack, networking created by another stack, that networking stack for the production one may be very heavyweight. It may have lots of things around there on security and logging and all that kind of stuff. But to test my own infrastructure that I'm working on for one small part, I don't necessarily want to have to stand up and provision lots of other things, or to use a shared environment that other people are doing things in. So what you can do is say, the only thing I need to test my stack for simple tests is just a subnet. So I can create a subnet and provision my stack to use that subnet, and then run some tests to make sure that I catch problems before I go into those kind of integration stages. All right, so then in the downstream environments, we're provisioning our stack in with other things so that we can test at the higher level. So does it all hang together nicely? We can do that kind of progressive testing. And so a common issue is multiple environments when we have like development, testing, staging, and production, and so on for our applications. How do we manage the infrastructure code for that? And what many people are doing is something that turns out to be kind of like snowflakes as code, right? So you have a separate copy of infrastructure code for each environment. Maybe you do that by having a folder structure, right? And so you copy and paste changes between these. And this tends to lead to inconsistencies and problems in promoting changes. Another way that people will do it sometimes is with branches, where they're saying we're going to have a separate branch for each of our environments, and then we're going to edit. It's not necessarily bad to have branches as the way you're promoting code, but really the important thing is that you promote your stack code across those instances, across those environments, without changing the code. You shouldn't have to go in and edit the code for different environments. And if you do have differences between environments, let's say the size of a cluster is different in production than it is in a test environment, or the size of the amount of storage you're allocating or memory or what have you. The way you do that is you pull out those and use parameters. And so you have, for each environment, you have some parameters that you pass in. And so you kind of keep the code consistent so that you can deploy it across environments. And then you can version the code for your stacks. So you can put version numbers on that and promote that version across across the pipeline. If it fails testing somewhere, then you make a new version with the fix and then push that through the pipeline from the beginning again. And you do this with your infrastructure just as you do with your applications. And that can also help with debugging. If you put that version number somewhere into your infrastructure, so you can get that visibility of, okay, what version of code has been applied to this infrastructure instance here in this environment, that can really help with debugging and troubleshooting. And then you want to be able to deliver your stacks independently from one another, right? So basically, I've got these three buckets, or sorry, these three stacks. One for the bucket, one for the networks, one for the roles. This is my static thing. And the idea is that I should be able to make changes to any one of these things and push it all the way through the environments into production without having to stop and coordinate with other parts of the system. And so this is what kind of keeps you nimble and keeps you able to kind of deploy and make fixes and updates very quickly, rather than kind of having a really slow pace of change, because you've got to kind of schedule when you're going to test everything all together in different environments. So you run your tests for everything across it. You deploy into that dev environment, you run your tests across everything and make sure it works. But if it doesn't work, you've only changed one thing, right? Because that time that you run the test is because we changed one of those inputs, one of those stacks, rather than having to, a bunch of different teams have pushed in all their changes and something fails, and then you have to figure out where did what caused that failure. So just to kind of wrap up, again, what I've kind of recommended here is that you think about ways to implement your platforms in a collaborative way that kind of empower teams and let them work together, rather than trying to centralize it and limit and disempower teams. That we look at having an infrastructure architecture that is composable, so that we have nicely designed components that are loosely coupled, and that we make sure that we have the mechanisms in place to be able to continuously deliver and evolve and improve those systems. Thanks very much. I think we should have some time for questions.
Thank you very much for your talk. Yes, we have a few of them. The first one would be, could you tell about your favorite monitoring tools to analyze the architecture of the project and if it fits the company? Maybe any other useful tools that you use daily in cloud services for monitoring?
For monitoring, so I've used different tools. What I'll tend to do, I'll tend to use the clouds, what they provided for the kind of first iterations of a project as we're building this. So I like to build infrastructure kind of iteratively and incrementally, so that we can kind of get applications kind of going quickly. And so we'll use those and then bring in tools. I kind of like Prometheus as a tool, but I haven't used all the tools that are out there. So I can't really kind of, say what's necessarily better or worse than others on that.
Thank you. We have a few more questions that are typing in. People are typing them right now. May I ask a question? From your point of view, we are going, the technology world is going in a direction where the cloud is one of the basic skills for newly for developers that are starting their world. And the question is, what do you think is the best way for them to fit this world? Not to just use what they have from DevOps, but to really understand how to work with it and what's a good starting point.
Oh gosh, there's so much of it. It's really hard to keep up with. I think it's useful to kind of go through like building things from scratch, and those kind of lower level things. So for example, you have like the Kubernetes the hard way tutorials, right? Which say you're probably not going to do that for your actual production and your actual Kubernetes clusters, but going through that exercise of like putting together the pieces, by hand, as it were, helps you to kind of understand what's going on. So then even though you might be using, say, a cloud provided EKS, AKS, GKS kind of Kubernetes implementation, you know a lot more about what's going on once you've done that kind of thing.
Thanks. The next question is, have you used Terraform extension tools such as TerraGrant, and what was the experience? Do they simplify development and deployment?
Yeah, I mean, You know, Terragrunt and other tools like that, they can be helpful, right? Because I think part of what's going on right now when it comes to infrastructure as code tools is there's not much of a maturity, and so we tend to write our own scripts for doing all kinds of things. And I used to do this when I was kind of in the world of Java development, say 20 years ago. We would have Ant as a build tool, and every project had their own special Ant script. And so I see the same thing happening with infrastructure projects right now. So having more standardized tools that have a kind of conventions for here's how to organize your code, here's how to manage the code across different environments, I think is really helpful. I'm still not quite satisfied with the tools that are out there in terms of what I've just described about using the stack and reusing stack code. Most tools seem to really focus on modules as a way of kind of reusing and promoting code. And I'm less, I think there's better ways to do that, but the tooling doesn't help.
Thank you. I think we can continue our discussion in a Discord voice chat.